Hello, my name is Sunny, and I'm a third-year bio major. I'm here to discuss a stoichiometry problem. So let's see what the problem says. The problem says that potassium nitrate decomposes on heating and produces potassium oxide, as well as gaseous nitrogen and oxygen. So put that into an equation. We write potassium nitrate gives you potassium oxide plus oxygen and nitrogen. So now, we first, every time you approach a problem like this, you must make sure that the equation that is given to you, or the reaction equation that's given to you, is balanced. So in this case, we are given a balanced equation, so we don't have to worry about that. So that would be 4 potassium nitrate, 2 potassium oxide, 5 oxygen, and 2 nitrogens. So now, the question asks us, if you produce 56.6 grams of oxygen, how many moles of potassium nitrate did you heat? And B, how many grams of potassium nitrate did you heat? To first approach this problem, let's talk about the concept of moles. So whenever you are given a problem like this, you have to make sure that you convert all the weights that you are given into moles. And this is because moles is a standard where 1 mole equals to 6.022 times 10 to the positive 23 of something. So in this case, it would be atoms or molecules of whatever we are calculating the moles of. So now, calculating it to moles allows us to do accurate predictions from like the stoichiometric ratios that are given to us. So now what we know that finding out moles is necessary, this equation lets us interconvert between moles, weight, and molecular weight. So the equation says moles of something equals to its weight divided by its molar weight or molecular weight. So now let's get back to the problem. So we were told we have 56.6 grams of oxygen. So as we talked earlier, we need to convert this to moles, and the molecular weight of oxygen is 32 grams per mole. You can calculate this by just looking at the periodic table, and you find out each atom of oxygen weighs 16 grams per mole, therefore O2 will be 32 grams per mole. So now, if you want to find out how many moles 56.6 grams of oxygen is, you apply the formula and you find out that the answer is 1.77 moles. So now we have the number of moles of oxygen that were produced. So if we look at the ratios from the reaction before, we find out that 4 potassium nitrates produce a ratio of 5 oxygens. So if you figure that out, you look at the ratios, then you can say that the moles, the 5 times moles of oxygen will equal to 4 moles of the potassium nitrate. So if you have this equation right here, so if you want to figure out the moles of potassium nitrate, all you have to do is multiply 4 over 5, because of the ratios, to the moles of oxygen. And that will give you the amount of oh, my bad, not O2, should be potassium nitrate. That will give you the amount of potassium nitrate that was heated. So we do some calculations. 4 over 5 times 1.77, and that will give us 1.416 moles. So that's our answer to part A. 1.416 moles of potassium nitrate were heated to produce 56.6 grams of oxygen. So now we move on to part B, which is way simpler than part A. Once you already have the moles, first you have to do grams of potassium nitrate. So we already know that moles of potassium nitrate that were produced was 1.416 moles. So now we just use the equation again, where it was moles equal weight over molecular weight. So if you find out the molecular weight of potassium nitrate is going to be around 101.1 grams per mole, you can look this up again on the internet or just calculate it from the periodic table. So all we have to do is plug and chug, and we find out that weight of potassium nitrate equals 1.416 times 101.1 grams per mole. There's moles right there. And we figure out that we get 143.16 grams. So this will be the answer to part B. To summarize how you approach problems like this: 1, you gotta always make sure the reactions equation is balanced. If you don't, all the answers that you would get are gonna be completely off. 2, never compare the grams / weight. These ratios are off. All you want to compare the amount of atoms that are reacting and producing the stuff. So you never want to produce grams or never want to compare the grams or the weight. And 3, always convert to moles. So if you remember these 3 things, you should be good on any problem that is similar to these stoichiometry problems like the one we just solved. So that's about it. Thank you, and have a great day.